Hello everyone, welcome to my channel. In this video, we are going to understand how a NAND gate works using NPN transistors. First, let's look at the components used in this circuit. We are using 3 batteries, 1 LED, 3 resistors, and 2 NPN transistors. Out of the 3 batteries, 2 batteries are used as the inputs of the NAND gate, and a third battery is used to power the circuit. The LED in this circuit acts as the output indicator, so we can easily see whether the output is high or low. The resistors are used to limit the current and properly bias the transistors. Before we understand the circuit, let's quickly see what a NAND gate is. A NAND gate is a digital logic gate that gives an output of 0 only when both inputs are 1. For all other input combinations, the output is 1. Now let's see how this circuit works. In this circuit, we are using 2 NPN transistors connected in series. The collector of the first transistor is connected to the LED and the supply battery through a resistor. The emitter of the first transistor is connected to the collector of the second transistor, and the emitter of the second transistor is connected to ground. The base of the first transistor receives input A through a resistor, and the base of the second transistor receives input B through another resistor. Now let's check the different input conditions. First case, when both inputs are 0. Both transistors remain off, so current flows through the LED and the LED turns on. This means the output is 1. Second case, when A is 1 and B is 0. The first transistor turns on, but the second transistor remains off, so the path is incomplete and the LED stays on. The output is still 1. Third case, when A is 0 and B is 1. The second transistor turns on, but the first transistor remains off, so again the LED stays on and the output is 1. Final case, when both inputs are 1. Now both transistors turn on and a path is created from the LED through both transistors to ground. Because of this, the LED turns off and the output becomes 0. So the LED turns off only when both inputs are 1, which matches the behavior of a NAND gate. If you look at the graphs in the simulation, you can see 3 waveforms. The first graph represents input A, the second graph represents input B, and the third graph represents the output, which is the LED. We can also verify this using the truth table. When A and B are 1 and 1, the output is 0. When A and B are 0 and 0, the output is 1. When A is 0 and B is 1, the output is 1. And when A is 1 and B is 0, the output is also 1. This clearly shows that the output becomes 0 only when both inputs are 1, which is the behavior of a NAND gate. Thank you for watching, and don't forget to like, share and subscribe for more electronics explanations.